So this is a problem, a trig problem actually, that we're going to try to finish. So it says here the number of hours of daylight varies sinusoidally throughout the year. The maximum occurs on the summer solstice, June 21st, when we have 15 hours and 50 minutes of daylight. The minimum occurs on the winter solstice, December 21st. We have 8 hours and 33 minutes of daylight. So this is what we're supposed to do. Find a formula for the function to describe this. So if it's sinusoidal and we want to find a formula, so we're going to find a trig formula, sine or cosine, that's going to go through the 2 points that have been given to us. So I'm going to take some notes, I'm going to write some things down and do some math, and hopefully we'll get through this. Okay, so they say on... My cats are a little hungry right now, so if they start making noise, just ignore it. So we know that June 21st, there is 15 hours and 50 minutes of daylight. And December 21st, there is 8 hours and 33 minutes of daylight. Okay. Now, this is going to be our ordered pairs right here. They say the input of your function should be d, the number of days since beginning of the year. So d equals 5 is on January 5th. So I have to figure out how many days have passed by this time and how many days have passed by this time. So that's the first part of my ordered pair here. Then it says the output of your function should be the amount of daylight in minutes. Okay, so it gives us, we were trying to find a formula. The input is number of days since beginning of the year. The output is the amount of daylight in minutes. Not a leap year, that's important. All right, so they tell you it's easier to write a cosine function, so I am going to do a cosine function, but you can do sine, cosine, negative cosine, any of those, and it should work. So I have to figure out, let's start with doing the output, determining how many minutes the sun is up. So I just have to convert hours to minutes by multiplying by 60. That's an easy one to convert. So 15 times 60, and then I have to add 50 for the total number of minutes. The sun is up in June, so that's 950. And then down here, 8 hours and 33 minutes. So it's going to be 8 hours times 60 plus 33 for the total number of minutes, 513. All right, so now we have to figure out the number of days that passed. So you should know, honestly, or know a trick to figure out the number of days that are in every month of the calendar year. This is not something that you should just assume that you can look at a calendar and do this. You should know this kind of stuff. Okay, so what I'm going to do is go up here, and I'm just going to say, all right, in January, we have 31 days. February, we have 28 days. March, 31. April, 30. And May is 31. And then plus the 21 for June 21st. All right, that'll give us our input right here. So let's get out your calculator and add those up. So we got 31 plus 28 plus 31 plus 30 plus 31 plus 21. Is that right? January, February, March, April, May, June. So it gives me 172 days. So 172. And so now I'm going to continue. May, June is 30 days. July is 31 days. August is 31 days. September is 30 days. October is 31 days. November is 30 days. And I have to add 21 for December 21st. Okay. So if I can go to my calculator again, you always, students, always want to spend the shortest amount of time working. So I do second enter to get the previous line, and I'm going to take off 21 here. I'm going to put in actual June 30 plus 31 plus 31 plus 30 plus 31 plus 30 plus 21. 355. So December 21st is 355 days away. So 355. All right, so I have two ordered pairs, and I'm going to plot them on the graph, and I'm going to find all the transformations and come up with a graph. All right, so that's January 1st right here. And then these are the days since January 1st. So I'm not going to do a bunch of little tick marks. I'm just going to say June 21st is here. December 21st is here. And then the same distance away from June 21st is December 21st again. That's why it's called sinusoidal. Okay, not a little crooked, but you'll live. So June 21st, I should be at 950 minutes. And at December, I should be 513 minutes. Five, 1, 3. And I draw my little graph. So it should come up like this. Right? All right, so low point, high point. So if I think about my cosine function, it's going to continue like this. Okay, off to the side. And so I'm kind of looking at this piece here as being my cosine function. But besides that, let's think about what one period is. Even if I just look at this piece, one period is 365 days. Now, you can do 365.25, but let's just leave it $365 or days for sanity's sake. Now, the other things I need, so I need the period, which is 365 days. I need the amplitude. So the amplitude is going to be the distance from the midline to the top hill or the bottom hill, okay? That's the amplitude right there. So how do I get that? Well, I can get the distance by taking this whole distance here by taking 950 minus 513. That'll give me my whole distance. Then I have to divide by 2 to get the half. All right, that's the number I want. So I take 950 minus 513. That gives me 437. And I divide it by 2 to get the amplitude, 218.5. So this distance here is 218.5. So to find, so let me write that down, 218.5. Then, I'm writing it down, sorry. Period 365 days, amplitude 218, midline is taking 513 and adding the amplitude of 218. So I take 513 and add it to 218. So this is going to take the answer from here and add 513. So 731.5. So my midline is at y equals 731.5. So your typical cosine starts at the top of the hill and goes down to the bottom and then goes back up to the top. So I have to think about, well, how much has it shifted from where it normally starts? Because normally a cosine function starts at the top of the hill right here and then goes down. Graph it on your calculator, cosine x, just to show the basic shape. But I have shifted this over at least June 21st number of days, which I know is 172. And so that's a 172 units, right, shift. So shift right, 172 units. Okay? So I'm just going to take all these numbers and put it together. So I need to think about having my equation, y equals a cosine bx, parenthesis there, sorry, x minus c plus d. Some of these are easy and some of these are harder. So A is 218 for the amplitude, 218.5. D is where the midline is. So D is going to be 731.5. The value for B has to do with the period. So I know that B is equal to 2 pi over the period. Now, that doesn't simplify nicely, so I'm just going to leave it 2 pi over 365. Now, if I want to shift right, that means C is going to be 172. So I put all this together. I have y equals 218.5 cosine 2 pi over 365, and in parentheses, x minus 172 plus 731.5. All right, now, that's nice that we have all that. What we have to do now is make sure that the data goes through this particular equation on my graphing calculator. Okay, so let's move this over a little bit. So we have our equation. Put my graphing calculator right here, and let's plot it. All right. So y equals 218.5 cosine, and I would put the 2 pi over 365 in parentheses. And then the parentheses for the x minus 172. Then I need another parenthesis. I need this parenthesis here to close off that parenthesis there. If you don't do it, it screws up pretty badly, so pay attention to that. Plus 731.5. Now I'm going to go to my window, and I'm going to think about this picture that I drew up here. And it looks like, you know, I need to have at least 365 days to get all the way to the end of the year. I need to make sure that I go from 0 to at least 950. So I'm going to do mine from 0 to 355. Well, I guess I'll do it for 355, so I end at December 1st right here. And if I do this one here, let's see, how many days from January is that? It's 10 days. So I guess I could do minus 10. Whoops. It's the wrong minus symbol. I did 30 because there's about 30 days in every month. And then 0 to 1,000 with a y-scale of 100. So now let's graph it. So here it comes. Looks pretty good. All right, so let's test it. If I hit the trace key, I should be able to type in 172 and my output should be 950. Okay, so 172, and look, I get 950. I should also be able to type in 355 and get 513, which it's not exact, but pretty close. So it looks like my model works. Here it is down here. 218.5 cosine of 2 pi over 365 times the quantity of x minus 172 plus 731.5.